In this video, we're going to look at a couple examples of calculating density. Now, these problems aren't too bad, but you have to be careful with your algebra, and you also need to be aware of the units. So, in this first problem, we're told that the density of radium is 5.5 grams per centimeters cubed, and we're asked to calculate the volume of a 14.8 milligram sample of radium. So, the first thing we need to do is remember the formula for density. And so we know that density is equal to the mass over the volume. And so they've given us the density, and they've given us the mass in milligrams. And so I have two of the variables, and I just need to solve for the third one. The other thing I need to be aware of is the units that I'm using for the mass and the volume have to match the units that the density is given in. So in this case, they want the volume in centimeters cubed, and that's good because that's what we have for the volume units on the density, but they also want the mass, or we've been given the mass in milligrams, and in the density, the mass is in grams. So I either need to convert the density to milligrams per centimeter cubed, or I need to convert my mass from milligrams into grams. And I think it's probably easier to do the second one. And so I'm going to convert my milligrams to grams. Then I know two of the variables. I can solve for the third, and so then it just becomes an algebra problem. So the first thing I need to do is convert this into grams. So we need to remember our conversion between grams and milligrams. So we know that 1 milligram is 10 to the minus third grams. Remember that milli is one of the prefixes that I want you to know, and also that when I write these conversion factors, the 1 always goes with the side that has the prefix, and the power of 10 goes with the base unit, right? The one that doesn't have a prefix. So now I'm ready to do my unit conversion. So I can write down what I'm given. And then, because I'm starting with milligrams, the milligrams has to go in the denominator. So I look at my conversion factor. So I have the 1 milligram, so that has to go in the denominator. And then the 10 to the minus third grams will go on top. So my milligrams cancel. I'm left with units of grams. And when I multiply that out, I'm going to get all right, so now I have the mass in the right units. I know my density. So there are two strategies at this point. I can either plug in my numbers into this equation directly and then solve for the volume. And that works perfectly well, but I always prefer to rearrange my equation first, solve for the variable I'm looking for, and then plug in the units. And that makes it easier to cancel, or plug in the values, and that makes it easier to cancel the units out. So if I start with this, and I need to get volume by itself, anytime the variable you're solving for is in the denominator, the first thing you want to do is get that out. And so to get v out of the denominator, I'm going to multiply both sides by v. So now I'm left with volume times density is equal to mass. So now to solve for the volume, I'll divide both sides by the density. All right, so my equation rearranged is V is equal to M over D. Be sure and do this algebra step carefully. One of the most common things I see is people don't solve for the volume correctly, and they get messed up when the volume is in the denominator, and they try to just divide both sides by M, and so they have D over M is equal to V, and obviously we can see that's incorrect. So now that I solve for the volume, I can plug in my variables, and so the volume is the mass divided by the density and I'm left with a value, and I always need to be sure to put the units on. The grams are going to cancel, and essentially I'm left with 1 over centimeters cubed, so that's going to be centimeters cubed.